How is everybody?
Oh, I was rather frustrated by the review, but other than that,
Yeah.
I know. Drives me crazy.
I didn't like the questions in the beginning that were asking you which ones are which.
Yeah, I don't like those either.
I didn't like those either. There's a few others too that I'm kind of struggling with. So I don't know. You know, you think you know the material, and then you come across this, and
Yep.
it's like I know nothing. I'm failed. So
It's very frustrating. It is.
not to mention that everybody else has this week off. Why don't they give us this week off? That just irritates me. I've got other things to do.
Yeah.
So,
I hear you.
but oh well. Too, we have to do a case study on Saturday.
Oh, you do?
Yes.
Wow.
It just doesn't make sense to me if the rest of the university has the week off, why online students don't.
Yeah.
But oh well, it is what it is.
Yeah.
And we
I've
have
always
less
wondered
than a
that
month.
too. Since I've been on BYU Idaho online, I've noticed that we don't get as much time off as the other people.
Really?
Yeah. I mean, between the trimesters, there's the same amount, but like holidays, they don't really give us holidays off.
No, we don't get the holidays off. Obviously.
I didn't realize
this class is a little bit shorter, but still.
There she is.
All right.
Sorry, now
okay, that's
my
off.
computer to Hi.
Hello.
I sort of hate technology.
I sort of don't blame you.
Computer to work in. It's working the last 2 weeks, and now I'm back on my phone. All right, are we ready to start?
Let's get started.
I went through this test and I feel like I know nothing.
We were just that way. You know, the other thing that occurred to me this morning is the TA has not joined any of our groups yet. And, you know, he sent out like 2 different emails or something asking when our groups met. And I emailed him back, told him that, and we haven't heard back from him at all.
You're right.
So, all right. So on the first 4 questions, we're supposed to decide which hypothesis test to use, and here's the list. For each question, identify the one hypothesis test that is most appropriate to the given situation. So number 1, in an article in the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. One set of data compared educational level of people who manage successful startup companies in the United States and Korea. You want to determine if education level differs between managers of successful startup companies differs between these 2 countries. Which hypothesis test would be most appropriate for this analysis?
The right answer is yeah. You go ahead. Go ahead.
Oh, I was going to say I thought maybe the chi-square because they were.
That's what I chose too.
I did too.
Okay.
Right. Chi-square. Chi-square. Right.
Chi-square.
Yeah.
All right, can we just end now and call it 100%?
Yeah.
Sure.
I missed the one. I missed the one. Because of
Only one.
I typed one. I typed wrong. I'm not the right answer, but I typed wrong. So I missed the one.
That's wishful thinking for me, John. Wishful
Yeah.
thinking to only miss one.
Yeah.
Yes.
You're brilliant, John.
All right, number
Okay, so
2.
number 3, a human resources manager reported data from a recent involuntary reduction in. You are an attorney and want to determine if age discrimination was a factor. It is illegal to discriminate against employees because of age. The company reported the number of employees in 2 groups, 40 years old or younger and 40 years old. Wait, yeah, 40, what? And over 40 years old, sorry.
Over.
They also reported the number of employees in each group who were terminated. You want to determine if both age groups were treated equally. Which hypothesis test would be most appropriate for this analysis? I feel like I'm on all
test
of
of
these.
2
That's why I'm
proportions.
silent.
I did too.
That's what I guessed also, but it's just a guess for me. I don't know.
I
That
know.
makes sense
Yeah.
to me, but I don't know if it's right.
Test of 2 proportions.
2 proportions?
Is that right, John?
Yes, test of 2 proportions.
All right.
Yeah.
Good.
Okay.
Yay.
2 of 2.
Hey.
We're on a roll.
All right.
All right, number 4.
3.
3? No.
4. Question 4.
No, the one about the lotteries, number 4 or number 3.
We just did number 3.
Are you on the right one, Kelly?
No, I thought we did the 40 years old and the 40.
We done 2 like math type or statistics type questions, but the first one is, did you participate in the group? So we're on the 3rd like test question.
Oh.
But the 4th test
Oh
question.
gosh,
But the 3rd.
I'm okay. Sorry, I'm on. You know what? I didn't even open up the quiz. The quiz. Sorry, I was going off of the lesson review questions. So yes, number 4, but it's the one about the lotteries, right?
Yes.
Number 4 is about the lottery.
Right.
Yes.
Okay, go ahead.
I can read it.
A survey was
Okay.
conducted by. Oh, okay. Go ahead.
No, it's okay. Oh, you want me to? All right. I wasn't sure. A survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 248 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5%. Which hypothesis test would be most appropriate for this analysis?
Test of 1 proportion.
Aha.
1
Right.
proportion.
1 proportion.
Okay, let's talk through that one because that's not what I put. But again, my answers were very much a guess.
So are mine.
I had the independent 2 sample test. So, but I was having a hard time understanding the numbers in this one. You know, when they said of the, you want to determine if the proportion of male heavy lottery players is different than the proportion of males. So I was having a hard time okay, are they talking about the proportion, the 152 heavy players out of the 48%? I don't know. I was having a hard time lining up all the numbers on this one.
I think, well, I don't know. John, why is it a test of one proportion?
Because you know, and you know that we want to tell, you know, totally, you know, is 248 among and among the number 152 were male. 以后这个，然后 we just to test why the proportion is different from the proportion of the population 48.5%. That's the reason why it's obviously it's one proportion.
Oh.
I think I got you.
Here,
Yeah, because the null hypothesis is that percentage.
yes.
Okay, I gotcha.
Okay.
I think.
I'm
Now, if
looking
there's
at the
words, I might not get it, but I think I understand this one.
if you look at the categorical data analysis, what is it? Excel sheet.
Mm-hmm.
I don't know. It just kind of shows you how the numbers would fit in there. I don't know. That's how I figured it out. How my brain works. I don't know.
Okay.
But
Oh,
Yeah, that
okay.
makes sense.
like you got the random sample.
Okay.
Believe.
So because you're doing it of so many out of so many, then it's a proportion of that. If it was just this many number people, then it wouldn't be a proportion of something. It'd just be like the one sample t-test or something like that. Right?
Yeah. Yeah.
Okay.
Yes,
you're
correct.
right. I think so.
Yeah, I think so.
Okay, I get it.
I kind of get it, but I don't know that I could get the right answer in the same situation. That's my,
Right. Right. If it was a
Sure.
different.
all right.
So I think if you like, if you're, you know how p hat is like the what is it? So like to find p hat, you would do the 148 or 152 out of 248, right? You do that. It gives you a proportion of something. Does that make sense?
Yeah.
The observation. So if you have to do that, then you're getting a proportion of the number, right? Percentage. Do you know what I'm saying?
Yeah.
So when you can do that, it's a test of one proportion because you're getting a proportion of the main sample.
I found the list.
That's
Right up out there with it.
Shh, go back outside and play. Yeah, go. Please. Okay, then you'll have to go up and take a nap. No, you can't be right here. Please go out right now.
Did Megan send a text?
No, she didn't. Go outside. Hurry.
Megan can't play.
Go, quickly. Sorry.
it's all right.
That's my youngest who thinks she can always just get whatever she wants.
Mm.
Okay. Are you getting it, Kelly, or did you?
No, but I don't think I'm going to. So we'll just move. The numbers in that one, I mean, I'll tell you what I'm not getting is, you know, you've got 248 people that are the heavy players, but then we're doing another number. And so, you know, the 248 is what percentage of 2406, and then the 152 are another percentage, but it's a different percentage of the 248, and I can't line up the numbers. It's just not making sense. So,
But 252 males that's not a percentage. That's just the number of males out of the 248 that were heavy hitters. So
Yeah,
Right.
the
152 males out of 248 is however many percent is a proportion compared to the proportion of how many males are in the population.
the first number, the survey of 4
But they don't even tell us.
is the trick.
They don't even tell us how many males are in the population, though. It just seems like we're missing information here. So, I just can't wrap my brain around it.
A full test, then you'd be missing information, but it's just asking you what kind of test you would use.
Yeah. I think
I don't know.
my brain is full.
It's yes, it's on overload. I hear you.
So I just need to move on and yeah, we'll just move on and maybe the light bulb will come on later. So
In the garbage. Go outside. My another daughter just came in and brought some pretty rocks, and one of them is a piece of hardened, chewed up gum.
Oh.
I really need you to go outside. Gross. Okay, so do you want to go on to number 5?
yep, let's go on.
It was just a text from Susan. Did we lose her?
Yeah, she's been in that position for a while. So there, you know what I mean? No,
I have to jump out and jump back in.
she's frozen there.
Give her.
Oh, she, so this test is just going to be basically the stuff that we've learned in the last 3 weeks, 2 weeks.
I think probably everything is fair game.
I think it's a conclusive test.
Oh, wow.
I bet most of the questions are what we've learned in the last 3 weeks, but I think you can still get some from before.
All right. Scary.
Right?
Yeah. Yeah.
I like when I learn about something, take a test, and then forget it.
I know.
I wish I didn't get it, but I do. So
Same here. I guess on this thing, maybe. Based on the, I like using the, what do you call them? The summaries on this, because at least it shows you like kind of a summary of everything.
main point. Yeah.
Which summaries are we talking about? Like at the end of each lesson or?
Yeah, but on the exam 3
Covered right.
thing, they have a summary lesson. They have lesson 16 recap, lesson 17 recap, 18 recap, and 19 recap.
And where's that at?
It's on the lesson
you're
20
back.
review for exam 3.
Uh-huh.
It's kind of at the top. Number 2, lesson summaries.
Oh. Okay. Oh, there's all your formulas
kinda-
too. Yeah,
And it
that
tells you the formulas. You can pull up a categorical data analysis Excel sheet. I wonder what the, what do you call it? The final exam's going to be like.
Oh, that just scares me.
Yeah, me too.
Oh no, when I opened this up today to start working on it, I got really discouraged really fast on it.
That's how I was too. Well, and I feel like I get the stuff that we do during the week.
I'm back.
Yay.
Oh,
Hi.
I feel like I get the stuff that we do each week, and then when we go to take a test or something, I can't translate that.
Yeah, I
can't
can't
take it
transfer
from
what I've been
we've done
doing.
every week.
Yeah, I know exactly what you're saying. Like I thought I knew what I was doing, but I can't seem to translate that into the answers for the test.
Right.
So,
I the way they're worded either. That is very frustrating to me because
Mhm.
I don't like the way it's worded. I think it's kind of tricky. Cranky.
All right. So number 5.
Oh, you waited for me. Thank you.
number 5.
A student project compared the effectiveness of 2 different combination locks. One of the locks turned clockwise first, and the other lock turned counterclockwise first. They asked 25 students to participate in the study. Each student was given the combination to each lock and asked to open the locks. The time it took them to open each lock was recorded. They want to determine if one of the locks is easier to open, which hypothesis test would be most appropriate for this analysis.
Yeah, parried sample t-test.
Okay, that's what I put.
That's what I put too.
Getting these. I don't
Thank
know
goodness.
how.
I was like, oh no.
Why is it paired samples and not independent samples? Oh, because one is dependent on the other. Okay, never mind. Sorry, that was a dumb question.
No
I got
questions. That was not done.
it.
For the next 3 questions, identify the one confidence interval that is most appropriate for the given situation. A bank employs 2 appraisers. When approving borrowers for mortgages, it is imperative that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers had recently valued. Which confidence interval would be most appropriate for this study?
Parried sample.
Here?
That's what I put again.
That's what I put.
Paired samples, T confidence interval.
Yes.
That's what I put too. Yay. I got most of those right. Well, so far. -1.
-1, that one.
Okay, number 7. In a Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting they were satisfied with their career paths was reported. The same data was also reported for accounting majors. You decide to construct a 95% confidence interval to see if the observed difference is significant. Which confidence interval would be most appropriate for this study?
For the 2 proportions.
Proportions. Yep.
For 2 proportions?
Yes.
Okay.
Yay.
Wow.
I put.
That's what I got.
All right. Should we go to number 8? Double stuffed Oreo cookies. Have twice the filling of regular Oreo cookies. You and some friends decide you want to know if that is a true assertion. Assertion. What makes them? You take a sample of 50 stuffed Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount of double stuff in order to compare it to the filling amount in regular Oreos. Which confidence interval would be most appropriate for this study?
One sample confidential interview.
Yes, that's the one I put.
Which
One
one is
sample. Number T.
One
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 One sample. One sample T confidence.
Yes.
All right. I did not get that one. Okay.
So on this one, you don't have a proportion like telling you that 10 out of 55 double stuffed cookies have this much. Do you know what I'm saying? That's not a proportion of it. So you know it's not the one proportion thing,
I didn't.
right?
No any proportion.
There's only one sample that you have. So
Yes.
it
Then
either
well,
has to be a Z confidence or a T confidence, and the Z confidence is when you know sigma, and T confidence is when you don't know sigma.
yes.
That was good. I was gonna ask that. I forgot. I forgot what the difference was. Okay.
Awesome. All right. Which one of the following best defines the notion of the significance level of a hypothesis test?
This one is a total guess for me. I have no idea. Not a total guess. I know it's not the first one, I think.
Actually, the first one is what I put.
See, I thought that was the p-value.
Well, you know, I Googled the p-value and actually came up with that the definition was the probability of the type 1 error. But yeah, both, yeah, which surprised me a little bit, but I don't know. John, help us in our cloudiness here.
Which cloud?
Number 9.
Number 9.
Number 9 is the type 1 error. The type 1 error.
That's what I guessed. That's what I put.
Because on the test last week, I think the p-value was the probability of exerming. It was the first one.
Yeah, that's the p-value.
Yeah, that's
Okay.
what I remember. I don't know. That's all I remember from that test. So,
Which is the answer to number 10. Which one of the following best defines the notion of value of a hypothesis test? So I put the third one. More extreme than one actually obtained, assuming the null hypothesis is true. That's what I had. Is that right, John? That's what I had.
Yeah, and you mean question 10?
Yes.
Question 10 is the third option.
Third option. Yeah. So yes, that's right. So number 9 is the second one, and number 10 is the third one.
Number 9 is the second one, and number 10 is the third. Right.
Okay. 11. Suppose you create a 95% confidence interval for a mean and get 10, 20. You've been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20. Exactly what does this mean? 1.
Yes, second.
Second one.
That's fine.
Second option.
All right. The next 3 questions I had no clue how to do.
I got 12 and actually, I don't know if I got 12. Yeah. First one, 12 I got, or maybe not. It's different questions. Sorry, I'm going from the review.
Okay, 12. 12, the answer
what's the mean of the distribution?
0.3. 0.3.
I mean, 0.3.
Yeah.
Okay, that's what I had. Because it's the
Yeah.
same, right? The mean is the same as the...
Yeah, p hat's the same as p.
Right. Okay, so that one I actually did have right. It's the next 2 that I don't know how to
Okay.
get.
That's the one I got to, and then yeah, 13. I just
Yeah, I
don't
don't.
know.
I don't know how to get. John, how do you do 13?
Okay, the 13 is 0.046.
Okay, but how did you get that?
And because I use the formula, you know, the deviation, the formula is deviation. Deviation is
Can you help us with that formula, John?
yes, the formula is T plus point 0.7 by 100. Then square root. We just use the formula.
What are the letters for the formula?
Square root p times 1 minus t
Minus T
divided by n.
by the number.
Divided by n.
And the whole thing is square.
I thought I had tried that and I wasn't coming up with a good number.
I'm gonna grab my.
Why don't I have it written down anywhere? Oh, there it is. P.
Oh,
It's
I
not
did
all
get that
square.
one.
It's the square root of.
Okay, I did get that one. It was the next one that I totally.
Standard deviation.
So is the whole thing square rooted or not?
Yeah, the whole
Yeah, it's
thing was
square
square.
root of P times 1 minus P
Okay.
all over.
Okay, very good. Thank you.
.046. Okay, I got it.
All right. That is actually the one that I did get. I found my formula somewhere and I did get that one. It's the next one, number 14. My hands and skipped.
Probability.
Proportional less than 0.25.
So is this where you have to find the standard deviation and then put not the standard deviation, the z-score, and then put the z-score in the normal probability outlet and find it that way?
Yes.
Yes, it is.
Yeah, I don't know.
Well, so you find p hat.
I mean, I remember doing these problems in an earlier lesson, but I looked back at the lessons and I couldn't find where that was, and so I gave up and skipped it.
Oh, Susan's gone again. Okay, so
Uh-oh. Let's see.
observation. Hey, Bella.
I popped out again. Can you hear me?
Never mind, I got it.
Can you all hear me?
Oh, yeah.
Yes.
Okay, good. I don't see you anymore, Tessa.
Oh, sorry, my phone's about to die, so I'm trying to find a charger.
All right. So we're still on 14. Did we get that answer?
We're on 14.
Okay.
Okay, so I don't know how to do 14.
That's the one I don't know how to do either.
And first, we can get the z-score. Use 0.3 minus 0.25, then divided by the division, we get the z-score. Then use the.
So where did you get the 0.25?
That's the
Yeah.
from the problem, from the question.
Okay, but I don't get that. I don't get it.
So they're asking what's the probability that our sample will have a sample proportion less than 0.25.
Oh, that question. Oh, okay, I gotcha. So this is the p hat minus p all over the formula for the standard deviation, right?
Say that again.
It's the formula for your z-score. So it's p hat minus p divided by the square root of p times 1 minus p over n.
Okay.
Square root of p times 1 minus p over n.
Yeah, so
which is your standard
minus
deviation.
p all over the standard deviation formula. And that gives you the z-score. And then you put the z-score in the normal probability applet. Is that right, John?
Yes, and the right answer is 0.138.
0.138.
Yes.
Okay, so all right. So okay. Going back to that though, so I got the z-score and then we put that into what formula?
You put it in the normal probability applet.
Oh, okay. Okay.
And then the box with the area is your p-value.
Right.
That's right. Oh, this test is gonna be a killer.
See, when we go through it like this, I'm like, oh yeah, that makes sense. I remember that. I'm gonna forget it by the time we take the next test.
I know, that's what I'm worried about too.
I wish he was doing his test review tonight instead of tomorrow night, because
Yeah,
I don't know if we can wait until Wednesday to take the test,
yeah.
because it's due Wednesday. All right, are we ready to go on?
Okay, you could go, sorry, you could go to work because every time I'm late here, sometimes the supervisor complains, and I can tell you the right answer, and yeah, you have to work for the remaining questions.
Okay,
Yeah.
and then we'll go through all of the questions together.
Yeah. Yeah.
Okay.
Yes.
Okay, I'm
And
good with that, John.
the 19, the question 15, the right answer is 0.016, 0.016.
I got that one right. Woohoo!
Oh, thank you. Yeah. Question,
Hey.
question 16, the negative 0.003, negative 0.003. Question 17, the answer is 0.029, 0.029.
29.
18, yeah, 29.
Okay.
The question 18, the first option.
First option.
Question, yeah.
Okay.
First option. The question 19. 19 is the answer is 1.458. 1.458. And the question 10. The answer is 0.1. 0.145. Question 21. Question 21 is the last option. Last option. Then the question 22. Question 22. The answer is 6.579. 6.579. Question 23. The answer is 0.087. 0.087. Question 24. 1, 2, 3, 4. Oh, the fourth option. The fourth option.
No, the p-value is greater than 0.05.
Yes, correct. Question 25. Question 25. The right answer is last one. Last option. 26. Question 26. The answer is 0.19. 0.19. Question 27. The answer is 0.31. 0.31. Question 28. The right answer is 1537. 1537.
1537. I still didn't hear.
1537.
Very good. Thank you.
Yeah. And then the question 29. Question 29 is the option is 1, 2, 3, 4, 5. Or the fifth are
P is greater than 0.2.
yes. The fifth option. Question 30. Question 30 is the right answer is option. First option. Question 31.
Oh, wait a minute. I didn't get 30. What was 30?
The first one?
Question. Yeah.
Okay.
Yeah. Question 30. The first one.
Okay.
Question 31. The right answer is 1.768. 1.768. Question 32. The p-value is 0.039. 0.039. Question 33. The answer is the first option. Yes, rejected that. Hypothesis 9. Hypothesis. The first option. Then the 34. Question 34. The right answer is 0.282. 282. Question 35. The answer is 0.293. 0.293. The question 30. Question 36. The answer is 99. 99. Question 37. The answer is negative 2.803. Negative 2.803. Question 38. The answer is the answer is 0.006. 0.006. Question 39. The right answer is first option. First option.
Stop, Simon. Simon. Seriously, Simon.
Okay. And then the question 40. Question 40. The right answer is 8.728. 8.728.
Okay, I'm sorry. I still is it 8.728?
Yes.
Yeah.
Okay, great. Thank you.
And question 41. The answer is 10.455. 10.455. Question 42. The right answer is 22.446. 22.446. Question 43. The question 43, the answer is 40. 40. Question 44. Answer is 0.000. Question 45. The right answer is let me see. Right answer is yeah, and the right answer is third option. The third option.
Third option.
Awesome.
Really sorry. I will go to work.
You're good.
Yeah.
Thank you for your help, John.
You're awesome, John. Thank you.
Sorry. Every time I come late here. Okay.
Thank you, dear.
Thanks, John.
Thank
Okay.
you.
See you.
Bye.
Good night.
I actually got all of those right, except for one.
Good for you.
Makes me really happy because I was totally stressed about it.
Wow.
Yeah.
All right. Started at number 15.
So what was number 14 again?
14 is 0.138.
Thank you.
Okay, so do you want to go through these now?
Yeah.
So on 15, I just put all of the information into the 2-sample z-test for proportions on the categorical data analysis. So in X1 is 61,
Yeah.
N1 is 1563,
Okay.
X2 is 15, and N2 is 579.
Right.
What type of test is this? Is this P1 is
A 2 proportion.
2-sample z-test for proportions so the 2 proportions on the categorical data analysis.
But is it P is greater than 1 or less than 1? Is that?
It's not equal to the type of test.
Oh, okay.
Is not equal.
Yeah. Yeah. Okay,
All right.
I'm sitting here, I'm trying to figure out where we got the margin of error from.
I just did the confidence interval thing where you
Okay, so you
take the
just
upper
figured it
bound.
from there. Okay,
Yep.
yep, okay.
And see, that was like a guess because I was just assuming that works with all confidence intervals.
Yeah,
It's the first confidence interval, right? The
yeah.
margin of error. Is that correct?
What?
That is the first part of the confidence interval formula. Isn't that the margin of error is the very first part? I'm not explaining myself.
Is what?
The first part of the formula with the anything, the next part beyond the Z of the formula, isn't that where your margin of error is? So that the part of that little formula, I don't have it in front of me.
I'm looking.
It's taking the difference of the upper and the lower bound and then divided in half. Error.
So the way that he told us to do it is the upper bound minus the lower bound divided by 2.
Okay.
So do the upper bound minus the lower bound and then divide that answer by 2.
Okay. Thank you.
All right, and on that same chart, then that gives us the test statistic.
Right, that's your Z. Z is the test statistic, 1.458.
1.458? Okay.
Mhm.
And then on question 20, we also get our p-value off of there, which is 0.145.
Mhm.
Okay. And those all I had all right.
And the p-value is 0.15. Okay. Reject it. Fail to reject the null.
So the last one, no, I failed to reject the null.
Right.
Okay. And on the evening person, morning person thing, then putting it into the,
That's you use the chi-squared
yeah,
sheet.
okay, there we go. That's the 6.579, so statistic. My tongue's getting all tangled.
And you get the p-value on there too.
Yes, yeah, p-value 0.087. Okay. And then 24, so 0.087, so that's greater than the 0.5, 0.05, so fail to reject.
Reject,
So
right.
no, the p-value is greater than, Okay.
Right.
Are we all up on this?
I accidentally put one of the numbers wrong in there. There we go.
On which one? Which one?
I on the chi-square, I accidentally put 133 instead of 131 in one of the numbers. So I was like, wait,
Oh,
the operator error.
operator error, huh? Is that what
Yeah.
we can say when we miss it on a test?
Yeah, operator error. Basically.
Yeah. Okay. And then see 25. And we got since we failed to reject, we have insufficient evidence to say that being a morning or evening person is not independent of age.
Right.
Okay. Okay.
On the
26.
chi-squared,
You guys-
the alternative hypothesis is always that it's not independent, and the null hypothesis is that
It's always
they are independent.
That's right. That's right.
So that's why you're choosing the last one instead of the first one.
Let me
I mean,
just
one above it.
ask a quick question. If we reject the null hypothesis and we have sufficient evidence to disprove the alternative.
Right.
So this is how I remember the crazy things you do to remember things, right? Okay. Fail to reject. 1, 2, 3, 4. Insufficient. 1, 2, 3, 4. 4 syllables, 4 words. That's how I remember. I think, Kelly, you were having trouble with remembering if you have sufficient evidence or insufficient. So just remember that.
Yeah, yeah.
Good way.
You know, I can use all the help I can get, believe me.
Why not? Me too.
Okay. So that's about as far as I got before we got together. So the rest of it I didn't have a chance to do ahead of time.
That's okay.
So 26, a recent book notes that only 20% of all investment managers outperform the Dow Jones Industrial Average. We had this on the practice. The random sample of 250 of these outperformed the Dow Jones Industrial Average. Let P be the true proportion, which the true proportion is that 0.2,
Yes.
right?
I have one of those too, Justin.
Oh, Cat, you're seeing this?
Yes.
He's my kitty.
Oh, this is the one. Okay, I was able to put this one into the categorical analysis. That's because this is under the 1 proportion.
Right.
Okay, all right. I'm still on track here then. This is still stuff that I did. Okay, so lower bound, let me make sure. Yes, I did get that lower bound and the upper bound. Am I the only one slowing things down here?
No,
No.
I'm too.
I care what you're all saying. Maybe I can suck it into my brain from yours.
Yeah.
Okay, I got
So
the
there-
upper bound and the lower bound on that.
And the
And
only
then-
thing you can't do from the Excel is number 28. You have to use that formula.
Okay,
All right.
okay. Which formula? This is the one I was trying to figure out when my time was up and we had to come online here.
Okay, so this, you know what the prior estimate is? So I sent you those 2 pictures. Do you remember, or I texted you the pictures that said this is the formula when you know the prior estimate, and this is the
Right.
formula when you don't.
So
those
that's
formula.
okay.
So it N, so when you know the prior estimate, it's N equals Z, I don't know what that's called. Z, what the little star, I forget what it's called.
Okay.
Over
Yeah,
M. And all of that squared.
Z over M
Here.
squared.
Let me.
And then, was it times the P times 1 minus P?
I don't know how to turn my phone around. It'd be easier just to. It's right. I tell because it's backwards to me. What is it? Z. Okay. So it's that one right there.
All right, let me. Okay, so the 2 over M squared and then P
No, it's just
star. What?
Z over M.
That's what I probably just said it wrong. Z over M squared and then times the P
star
times 1 minus P star. Now P star, is that our the 0.2?
Yes.
Yes.
Okay.
And M is the margin of error that you want. So
Okay.
the
Okay.
Z is the 1.96 because you're doing a 95% confidence interval. So the Z star thing is 1.96. M is 0.02.
Oh, that's where I messed up. So the Z star is the confidence interval one. The sorry, the
yes, I
it's
know.
not the test statistic from the spreadsheet. It's the normal whatever. I don't know what to call it.
It's the confidence interval. It's the confidence level from the. It's the, I don't even remember what it's called, but 95 is 1.96.
Yeah.
Okay, and see, I think what I did is I took the test statistic off of the spreadsheet. That's why I was having trouble with it.
Yeah, it's not
I had
Z,
like
because it's just Z that's the test statistic. It's the Z star thing is the confidence level.
The confidence level one. Okay. So
it's 1.96 over 0.02 and all of that squared.
Right.
Times 0.2 times 1 minus 0.2.
Start over on this. Okay, so 1.96 divided by 0.02.
And all of that.
And then square it.
Right.
Okay, and then we go the 0.2 times 0.8 times that other total.
Right. And it should be like
okay, so 1537. Okay.
6 point something, but you round up.
Okay. What was the other one that you texted me? Another one that said Z over 2M, and then that was squared.
You don't have the prior estimate.
If you don't have the prior estimate,
it gives you the prior estimate. If it doesn't give you it, then you use that other formula.
Okay, because you wouldn't have the P value, that P star value.
Right.
Okay. Okay. All right. All right, I think I've got that one. All right. Everybody else up with us? And
yeah. So.
Okay. So the next one is the which is most appropriate for addressing this question. So P equals 0.2 and the alternate would be P is greater than 0.2. Okay. All right. Look at that. Okay. All right, question 30. What requirements must be met to ensure that p hat is normally distributed? Okay, I think we beat that one like a dead horse.
Except I feel like I got it wrong on the last. I think it was a different question, but
I got it wrong too on the last quiz, and I don't know what I did wrong.
Well, because I think it was a different question, but
Yeah.
I got it right here, but I don't know why I got it right wrong the other time. So I have no idea.
I don't either. Okay. So the test statistic 6.8. See, that was what I was trying to plug into that other formula, was that 1.768, which is why I threw up my hands and gave up. So now I understand, though. Thank you for that. You gave a good explanation, Tessa. Okay. Question 32, the p-value of your test is 0.039, and I think that spreadsheet too,
Help you, sweetie.
isn't it?
Yes, it does.
Okay. All right. Okay. 33. Yes, I rejected the null.
Yep.
All right. Okay. And 30. Oh, this is where we've got to get our spreadsheet out here.
So this is a one sample t-test.
Yes. That's the one sample t-test. All right.
And you can. No, they can't be too hard. Sweetie,
So we're gonna.
go play game, Lila.
All right. One sample t-test, so we put in the lower bound. For some reason mine says 0.283. And I thought John gave us 282.
Mine says 282.
Mine says 282 also.
Well, I put it into the spreadsheet. What's the problem here?
I've had that problem too. And I don't know what causes it.
Okay, well, I'll keep the 0.282 and make sure that if that's the lower bound. I don't know why it would do the other. And then, wait, and then I've got 292 on the upper bound. But John gave us the 293.
That's
Okay. So I just hope my spreadsheet doesn't do that to me on the test. 293. I don't know. I hope my spreadsheet doesn't fail me during the test. That's all I can say. Okay, degrees of freedom 99. That's on there.
So do you have in your null hypothesis, do you have 0.295?
That make a difference in the. Wait. That may, okay. Right, 2 and 293. Okay, yep, that was my problem.
Good.
Thank you.
Yep.
All right. So degrees of freedom 99, 37. The test statistic.
And is this is it greater than, or is it not? Is it different?
It's not equal to. It tells you that in the problem.
Or does it?
In the information, that's where I got the null hypothesis number, the 0.295. It says to test the null hypothesis 0.295 against the alternative hypothesis, the mean is not equal to 0.295. You cannot keep reading it out loud.
Oh, okay.
There we go. And the type of test is not equal to, okay. Yeah, I just hadn't put all my numbers in. So negative 2.803. Yes. Okay.
All right. So I don't have that. I mean, I have, is it on the, I'm sorry, is it on the little formula, the negative 2.803? You have to calculate that. Because I don't have.
That's your T on the one sample t-test. That's the T right now,
Well,
degrees of freedom.
That's what I thought, but I have like negative 3683 on there. So what did I plug in wrong?
So do you have your confidence level set at 0.95 and your null hypothesis at 0.295? And it should be not equal to.
There it is. Thank you.
Mm-hmm.
But I did.
Did it correct?
Yes, it did.
Okay, good. Good, good. Then p-value 0.006.
Yay.
All right. Hey, every number that comes up right is a win.
Yeah.
You said it.
Okay.
Lost you guys somewhere.
39, based on the results of this test, what would you conclude? We have sufficient evidence to say that the true mean is different than 0.295. All right. So then the next one, we have the AM PM heights. And I can't believe they would do a test like that, that they would really think people are taller at one time of day than they are at the other. That seems silly to me.
Yeah.
Okay. So we're defining AM height minus PM height.
Differences. Okay.
So we're doing a paired.
Mm-hmm.
Okay.
Computer wants to work.
All right. So if we put all those in. And we're doing AM minus PM, right?
Right.
Okay. There. Confidence level is 0.95.
What number are we in?
Color in the morning, then in the evening. So type of test would be greater than. All right. Okay, my lower bound did not come up the same as his answer. I'm trying to figure out what. Oh, never mind. I think I figured it out. Okay, there we go. Had to fix a formula in my spreadsheet. All right. Okay, I got the upper and lower bounds. How about everybody else?
I did too.
Yep.
And I got the test
Yeah.
statistic on.
And the test statistic, 22.446. That came up right. And the degrees of freedom came up.
But my value did not.
Well, the p-value.
Remember,
It's
look at the end of
0.00.
your p-value where it says E minus 24.
Yeah. Oh,
So that means that you got 23 zeros in front of that one.
right.
We still have to round to 3.
Okay.
Decimal
Right.
place.
Very good.
We have to round to 0.003?
No, we have to round to 3. So that's why it's 000. Sorry.
Place it.
Okay.
But you can still just put 0 in your answers, right?
Yeah, you can.
Probably. Yeah.
You never know.
Okay. I know. I get surprised on some of these, so I always double check. Based on your results of the test, there's enough evidence to suggest, is there enough evidence to suggest that children are taller in the morning than evening? Yes, there is. See, that seems like such a silly test to me. It really does. Yes, because we rejected the null.
Yes.
How do kids shrink between morning and evening? Maybe they're just tired and they're slouched over.
Their spines. They, I don't know.
All right. Shall we submit?
Submit 100%. What time is he doing that review tomorrow?
Oh, yeah. Gotta do
I
that.
don't know. He said he was going to send out an email. Let me see if he did.
Okay, I thought maybe I missed something, but we're still waiting on it then. Okay.
No, says he's going to do it on Tuesday, but the test is only open until Wednesday, so.
I
Yeah.
know. Well, I'm working during the day tomorrow, so I'll just have to look at the. I'll have to just hopefully, watch the video after the fact. But I'm planning on taking the test probably tomorrow night, so I can just get it out of the way before all the festivities.
Very good.
So.
Yep.
I did hear back from, I sent a message to Brother Wilcox because asking him about the, the change he wanted us to make to the design of study.
Mhm.
And this is what he said. He said, here's the overall deal. I don't want you to get kicked out of the store or anything like that for messing with their product. Therefore, even if in practice you just grab the first 5 or 10 or whatever number of bags of M&Ms, I would be okay with that. However, I just need to see that you understand the concept or theory of random sampling. Thus, at least for the write-up for the design of the study, put in that you will put them in a hat or whatever method of random sampling you think would be appropriate. So,
Okay.
so I'm going to finish now. Just do it, John. The revision John sent me was kind of complicated, and so I'm trying to simplify it without really changing his work.
Sure.
You know what I mean?
Right.
And so I'm going to do that and send it back. But then we need to do the collect the data study and refresh my memory. When we do that, let's see, I think I've got the, yeah, when we fill out the Word document that he sent for the collect the data, are each of us doing that? Or is it just the person that's doing the collect and describe the data? Are we just turning in one document?
No, every person has to turn that in. So you're turning in a document for the data that you collected, and I'm turning in one for what I collected, and then
Okay.
I'll give all of that to Justin, and he'll put it all together.
Okay.
But do we have to each submit to Brother Wilcox this thing, or
Yeah.
are we just giving it all to Justin?